So the next part of talking about derivatives is how do you take the derivative when the function is involving trig functions. So that's section 3.6 is derivatives of trig functions. So the main two that we're going to look at, and you can derive all of the other ones from these two, the main one we're going to look at is the derivative of sine and the derivative of cosine. So derivative of cosine. It's almost like they bounce back and forth. So you want to say that the derivative of sine is cosine and that the derivative of cosine is sine. The only change you have to make is that actually the derivative of cosine is negative sine. So it's almost like they bounce back and forth between derivatives, but the derivative of cosine is negative sine instead of just sine. So those are your two derivatives. We're going to add these to the derivatives that we already know, and we're going to be able to take the derivative of a lot more functions. So let's do some examples here. What's the derivative of 5 sine x minus cosine x? Well, this is a sum, or subtraction and sum, really the same thing here. So I'm going to first take the derivative of 5 sine x. So 5 sine x, the derivative, I keep my 5 because that's a constant. Then the derivative of sine is cosine. Now I'm going to subtract the derivative of cosine, that was negative sine. So the derivative of my original function is 5 cosine x plus sine x. So those negatives cancel out. Okay, let's do another one. Let's find the derivative of e to the x sine x. So this function is e to the x times sine x, which means we have a product, so I'm going to have to use my product rule. So u here, e to the x, v sine x. We do the same thing that we've been doing before. The derivative of e to the x is just e to the x. The derivative of sine x, we set up here, is cosine x. So by the product rule, the derivative of my function is going to be u prime v plus u v prime. So there's my derivative. So just because we've learned these trig functions doesn't mean we should forget about the product rule or the quotient rule. These are just more individual derivatives to use within those. Let's do one more here. Let's find the derivative. So d dt of 5 sine t minus 5t squared over e to the t plus cosine of t. Here I have a quotient, so I'm going to let u be the numerator. So I have 5 sine t minus 5t squared, and I'm going to let v be the denominator. I just need to find u prime and v prime. Now remember, we don't have x's in this problem because the instructions said take the derivative with respect to t. So t is kind of like our variable. So the derivative of 5 sine t minus 5t squared, I'm just going to take the derivative of each piece and add them together. So the derivative of 5 sine t is going to be 5 cosine t. And then using the power rule, the derivative of negative 5t squared is minus 10t. Now the derivative of e to the t is just e to the t. And then the derivative of cosine t is minus sine t. Now that I have all four of these, I just plug it into my quotient rule. So the derivative of our function, so let's write it all out here, is u prime v, I'm going to use parentheses to kind of keep everything straight, times v here, so u prime v, minus u v prime all over v squared. So from the quotient rule, I was able to find out the derivative of my quotient. Okay, let's try something where we have to go back to a tangent line. So let's find the equation of the tangent line at x equals pi over 2 of the function x squared sine x plus cosine x. So we're trying to find the equation of a tangent line, so our answer is going to be of the form mx plus b. First thing I got to find is m. Whenever we have a function like this and we're looking for m, it's always f prime of the x value that we're looking for. So I got to find f prime, then I'm going to plug in pi over 2. So let's find f prime. So the first part of f prime is a product. So to find the derivative of that product, I'm going to let u be x squared, v be sine x, which means u prime is 2x, v prime is cosine x. So the derivative, once I use the product rule, is 2x sine x plus x squared cosine x. But that's only the derivative of this first piece. Remember, I have to add 2 at the derivative of cosine x, which is minus sine x. So there's my equation for f prime. Now I just plug in pi over 2. So I'll get 2 pi over 2 sine pi over 2 plus pi over 2 squared cosine pi over 2 minus sine pi over 2. So sine pi over 2 is equal to 1. Cosine pi over 2 is 0. So what do I get here? I get 2 pi over 2. This is 1. This whole term goes to 0. Minus 1. These 2's cancel, so I get pi minus 1. So now I have that the slope of my tangent line is pi minus 1. That's what that just told me. M is pi minus 1. Now I just need to figure out what is b. So to find b, we're always going to use the point pi over 2, because that's what we're looking at, f of pi over 2. What is f of pi over 2? Remember, this was the original function. So f of pi over 2 is going to be pi over 2 squared sine of pi over 2 plus cosine of pi over 2. Cosine of pi over 2 we already said is 0, sine of pi over 2 is 1. So this is just pi squared over 4 once I actually work that out. So the point that I'm going to use is pi over 2 pi squared over 4. Now let's plug that in. Currently, our line is pi minus 1x plus b. I'm going to plug in pi squared over 4 for y and pi over 2 for x. Now let's try to solve this for b. All I have to do is subtract this whole thing over to the other side. So I'll get pi squared over 4 minus pi minus 1, pi over 2 is equal to b. Now, of course, you could try to simplify this whole thing out. I don't think it's that necessary, so let's just leave it as is. So I'll get y was my slope plus my b.